Welcome to today's Roundtable webcast, brought to you by Percona, Couchbase, and ArongoDB. I'm Stephen Fegg, Director at Database Trends and Applications in Neunhöffer Research. I will be your host for today's broadcast. Our presentation today is titled Top Trends in Modern Data Architecture for 2019. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, all viewers today will be entered into a raffle to win a $100 American Express gift card. Now, to introduce our speakers for today, Michael Coburn, Product Manager at Percona, Tyler Mitchell, Senior Product Marketing Manager at Couchbase, and Max Neunhöffer, Senior Developer and Architect at ArongoDB. For more information on our speakers today, you can click on the arrows under their headshots. Now I'm going to pass the event over to Michael.
Thank you, Stephen. Welcome, everybody. I'm Michael Coburn. I'm the Product Manager for PMM and for Percona Toolkit at Percona, where we are the unbiased database open source champions, where we help customers through support contracts and other types of services to optimize and improve the performance of your database environment. I've been working with databases for about 15 years, and I'm happy to speak to you with regards to our top trends that we see in the database and open source space. I'd like to begin with commenting a little bit about some people that aren't in the open source space, and that's Oracle. They're a very popular database technology. They have a lot of groundswell. They've been the thought leaders and really invented a lot of what databases are today. But they also happen to have an open source part to them. They're also the owners of the MySQL open source database. And what we're seeing from Percona's perspective is that a lot of customers are coming to us and saying, we'd like to move away from this Oracle. We'd like to move on to something else, something a little bit different. And the reasons they're doing this, it's expensive to run Oracle. It's expensive in terms of the licensing that you pay them. And there's also some great alternatives out there from the open source space. A very similar comparison to Oracle is the Postgres database. And it's just recently been announced their version 11. What we're also seeing is that users want more than just a relational database model, that they're looking at things like Couchbase and ArongoDB and some others out there that let them do things like NoSQL. And that allows them to leave their data in some standardized formats, and they can query them in different ways with having to do expensive operations like joins and other operations that RDBMS enforce upon the data set. And the last thing I wanted to mention about Oracle and the move to open source databases is that cloud providers, the Amazon Web Services is probably the most prevalent, but we see Google through their SQL cloud, and also Microsoft Azure through their SQL side. They're very strong players, and they're providing some great tools to help you migrate off of Oracle and some of these other proprietary databases. Why might it be worthwhile to go to the cloud? That's one of our secondary topics that I wanted to bring up. What we see is a lot of companies want to see what they can do when they're not in an on-premise environment. As you're familiar with, the cloud's been around for quite some time now. Amazon Web Services is celebrating over a decade of operation. And some of the advantages mean that they aren't tied anymore so much to the single CPU licensing model that Oracle had for them. In fact, it allows them to kind of break away from that, and then the owners of the data can actually be the owners of the operations, that they aren't beholden to the owner of the database technology. Some other advantages of the cloud is that there's 24/7 availability, which means that there's a whole host of services and alerting mechanisms that are already wrapped around that database technology that otherwise you'd have to orchestrate yourself through your own team. And you might have some great success with that, and you might also struggle with that. One of the other advantages of having a cloud provider is that your data can automatically be replicated across multiple different locations. In the case of Amazon, having availability zone coverage through a system like Amazon RDS or through Aurora means that that data is automatically copied for you. Now, you need to pay for that service, but that's a value add that you don't need to spend any sweat equity or development time orchestrating. It just happens automatically once you click a button. Another great feature of the cloud, that means that the databases can grow basically on demand. Amazon has a particular feature called Amazon Aurora Serverless, which basically can detect a growth in the request to a database server and can automatically add extra capacity as needed without any involvement from yourselves or from your operational team. And finally, the cloud-based architectures allow you to respond to these periods of activity to scale up, but they can also scale back down, which means that they can save you a little bit of money in the long run. So they've increased your costs, but they can also do a little bit of recovery for you. Some things, though, to keep in mind, though, as you consider going to the cloud, particularly around where you're putting your data, you're giving it to someone else. Are you bound by any type of HIPAA legislation or any type of other concerns? GDPR might affect you in certain ways. All of these are concerns you need to explore with your cloud provider and make sure that they're able to accommodate your needs. And then you also need to audit that. Are you aware if they're actually sticking to their commitments? And that sometimes can be hard to do. Another component is around data security. There is always a possibility that you could be vulnerable to an exposure, whether it's through the database technology or through the provider itself. And what that means for providers is that that hack could expose you, and maybe you didn't have anything to do with it, and suddenly your data on your clients is out there and available to somebody else. And finally, one of the greatest concerns that we hear at Percona is that the databases in the cloud don't always have the same level of visibility as that you could get if you were running it yourselves. And what I mean by that is when we call these things databases as a service, they're generally hidden behind some sort of an artificial wall. They still might be running on bare metal or some other mechanism back there, but you don't have access to that. And that lessens your ability to decipher what's happening. Now, these cloud providers have great APIs, and I'll get into this later around how one of the products from Percona, PMM, can help you gain that visibility back. But by and large, you need to spend a little bit of extra effort to fully understand the operational characteristics and performance characteristics when you do move to the cloud. Looking at some facts that come in from outside of Percona, we see things that DBTA has reported, and we see cloud migrations are very popular. That's also held out through the work that we do at Percona. We're doing a lot more migrations from on-premise to the cloud or between cloud providers. And we're also hearing a lot of customers saying, we'd like to be in multi-cloud. We'd like to have some sort of multi-tenant availability here. Database performance has always been a hot button, and it's no lower than it's been before. We're talking about 65% of DBTA subscribers are talking about it now. And it's critical that you're able to maintain some high level of performance because that directly relates to your revenue and to the ability of your application to serve requests. And one of the last things that I wanted to mention is that NoSQL has had a lot of groundswell for the last almost decade, and it continues to run very strong. There's some large money that's moved into the venture capital space and is supporting a lot of these providers out there. And I think that's great for the market as a whole because NoSQL serves a different segment and utilization of applications. And we see that that is not dropping off at all. And so where we've moved, where's the data architecture evolving? What we're seeing is that more and more environments, more and more customers of Percona are not looking for a single database on the back end to do all of its work. Instead, they look at concepts like sharding or federation. And what they expect with this is that now the data has been segmented a lot smaller into many more smaller components. So a failure of one group or one node impacts that much less of their user base. It also makes doing upgrades and other types of operations a lot easier. Your support staff, your system, your engineers are much more appreciative when they can say, this operation I'm going to do will affect only 5% of our user base rather than 50%. And the other advantage to that is that when you're able to take them down, you can bring them back up faster. That means that you can add new nodes much more quickly. You can add capacity, take it from 5% to 7%. Whereas before, when you had a single monolithic database, it was an all or nothing approach. I want to speak now a little bit about the need for performance monitoring. Your performance monitoring directly relates to the value that you bring to the market. And this is simple in terms of how long does a page load take. If in your case it might take 5 seconds, that might be unacceptable to your users. If it's something that's coming back in a second or less, then that's an opportunity for you to capitalize on that. You can have them clicking through more pages. That might make moving through a shopping cart much more quickly, or adding more subscribers at a greater rate. So database performance is critical to the overall health of your application. And so where does performance monitoring come in? Well, you need to have the right interface for consumption here. We've talked about not having all of your data in a single monolithic system, which in that case, one bad query might take down the experience for many users. Having it spread across multiple different environments means one bad query might take down 5% of your users. So that's a big advantage. But what else? We've been talking about your online transaction processing, your OLTP. But there are other needs you have from your data. You might want to take today's sales transaction data and look at it across the last 30 days or last 365 days. Your database system that runs it for your website is not the right place to do that query. You want to move it to some other sort of platform, like an OLAP environment, and you'll use a different technology for that. But it's important that you're paying attention to both performance on the front end for your application and also on the back end for how long does it take to run these analytic reports. Are they coming back in the right amount of time? Can I make good business decisions off of them? It's also important that you maintain the same kind of language. That means that a developer that works on the front end in terms of your application serving your business card or your application can also help out on the back end with the data analytics. So using a common language like SQL is of critical importance. Okay. And what I'll move us to is an example of database monitoring using a product from Percona. It's called Percona Monitoring and Management. And this product is designed to work against MySQL, MongoDB, and PostgreSQL databases. And its value add is that it can observe at a very low granularity, at a 1-second granularity, the database characteristics that are most important to database administrators and application designers today. And so we gather this using other open source tools and present it in a very beautiful graphing interface. That's the first component where we can show metric behavior over time and help you make good business decisions on where to spend money in terms of scaling the capacity of your environment or removing nodes or helping you scale down perhaps. You've over-provisioned in one of your cloud providers. So doing performance monitoring means you can both make things faster but also save money by looking at it and saying, I'm over-provisioned, I have too much capacity here. The other important side of database monitoring is the queries themselves. We offer a query analytics environment, which means we track all of the queries that are coming into the database server, and we show you the ones that are spending the most time. And these are the ones that you bring back to your application development team and say, look, guys, this one query takes 30% of all the work that's happening on the server. If we could get that down to 5%, that might mean I could reduce our instance count. I could reduce the size of instances. There's a lot of money you could save there. You might be able to put off scaling for another 6 months or something. So it's critical that you look at tools such as PMM to be aware of how you can monitor your database environment. And so just to summarize, we're seeing a lot of migrations away from Oracle to other open source databases. Generally, PostgreSQL is the most common one because it's so similar in terms of the PL/SQL syntax. And we don't think this is going to slow down. We think Oracle still has a bright future ahead of them, but they're doing things a different way than open source works. And open source has a great amount of traction, and we're seeing a lot of adoption of open source database technology. We also don't think there's going to be any slowdown. In fact, we'll see probably a higher level of migrations to the cloud. People want to get out of on-premise because they're tired of paying a flat rate for electricity and other components, the server rack space. Instead, they can buy on demand from a cloud provider. I'll mention again that performance management is of critical value. It helps you both in terms of revenue attainment, but also minimizing your costs. So being able to look at it to say, if I can make my app faster, I can make more money. And if I can reduce my spend by downscaling some of my nodes, that also wins for me in the long term. And the last thing I'll mention is that it's important to keep in mind that there are more than one providers out there. Percona has worked with all of the large providers, and we have a great relationship with them. But they all have their own pros and cons, and it's important that you're aware of where their SLAs meet and where they work with you, and maybe some of them are better fits than others. But it's important that you take a look at probably more than one before you become committed to a single vendor. And if you're interested in learning more about Percona, we've got a number of articles on our blog site, percona.com/blog, and we've talked a lot about migrations and how we can save you money in terms of operating your environment, offering support contracts, and other types of consulting projects if you're looking for migrations. And finally, I'll again mention that we have a wonderful demo site for Percona Monitoring and Management. It's pmmdemo.percona.com. And I want to say thank you very much for your time today, and I'll hand it back to you, Stephen.
Thank you very much, Michael. We're now going to move on to our next speaker today, Tyler Mitchell, Senior Product Marketing Manager at Couchbase.
Hello, and thanks everyone for joining today. Appreciate having the opportunity to share a little bit of insights from my perspective about what we're watching for in 2019, the trends that we see happening in our side of the ecosystem. So we're a NoSQL, modern, scalable database, and coming from that angle, we're also open source and have an architecture that I'd like to share with you show how we address some of the trends that we see coming forward. So to start with, this is probably goes without saying at some level, but that systems are fueling interactions at an unprecedented level within enterprises today. The kinds of interactions and transactions we've talked about historically, whether they're like internal systems or just booking systems, etc., are somewhat getting old. The concept is ramping up, and we are moving the data closer to the end user and closer than ever before. So the end user is interacting with kind of our data management systems with a very thin layer in between so that we're out of the way and keep things running efficiently. And if you just even think about the differences between these three different kinds of end users of an enterprise system, you've got machines that are just sharing kind of regular information. You've got kind of more transactions happening all the time with those machines. Employees through supply chain tooling would be, there will be even more transactions going on there. But a customer, if you think of a customer of like, say, a travel booking system, they're going to have all this interaction go on before they ever make an actual purchase or a transaction. So this idea that we have interactions galore that end up leading to a small number of actual transactions, we need to be able to capture and integrate that information into our data management systems more than ever. So Couchbase is positioned to kind of address these multiple types of use cases with different levels of impedance coming from the end user. So for example, a customer of a booking system might do 1,000 interactions before they actually do one transaction at the end of the day. Well, we need databases that can support that kind of level of interactivity. And that's really where we're positioning ourselves. But that's kind of keep that in mind, that these kinds of demands are growing. There's a different kind of frequency, different kind of speed for different kinds of databases. And the foundation of any kind of data management system, I'll just say database in this case, any kind of database foundation has to be architected to handle these various use cases. It's not just a matter of scaling up a regular transactional system. Like a general platform just isn't enough. It has to handle these and be able to scale up. And we'll talk a little bit about scalability in a minute. So there's just three areas that are three challenges that we see when we talk about massively interactive applications. And these are the three areas that I'd like to talk about briefly today. One is the database sprawl, the idea that we have every time we want a new feature or a new kind of service added on top of our data, we have to install new products, new applications, new modules. And some of this goes back to the open source concept of just taking the best tool for the job and adding it in a modular approach. So that ends up ultimately having some of the database sprawling challenges that companies have. All these many systems to manage. Some of them are for small use cases, some of them are for larger ones. Secondly, the idea of scaling not being easy or not being successful. It's a common challenge that we're hearing from our customers, and this is what we're trying to address. And everyone will have to address this, from the developer to the architect to the business user. Will all need to consider how they're scaling their solution. And then third, which we've already heard a little bit about, the idea of having multi-cloud manageability. People want to move to the cloud, but people want to also have their private cloud. They also want to have hybrid options for replication, etc. And they need management interfaces on top of that, but they don't necessarily have all those tools that they need to be successful. So my predictions for 2019 is there will be more integration between different services on platforms. There will be more demand for scalability, and there will be more manageability options. So we'll talk through each of those. Sorry, I forgot to press the next slide button here. But these are the 3 points I've just been talking about. Thanks. So the 2019, we'll see addressing each of these three scenarios for sure. So moving on to addressing the first one, integrated data platforms. And by this, I mean we don't just talk about database in isolation and then have data processing as another component outside of the database, or analytics outside the database. Moving things between systems is becoming real old school, and more pressure is being put on vendors to create the solutions that are integrated. And the goal of this is to have the lowest amount of friction possible to accessing, for users to access their data. We don't need them to jump through multiple hoops. We don't need a whole bunch of integrations between multiple external components. We want to kind of keep it as tight as possible, and we want to keep those applications as close to the data as possible without having to make copies of it all over the place. So this is just an overview of our platform in a kind of a somewhat digestible way. The real important point is to kind of start with the red center chunk here. These are really the core principles that you need to have for a data platform that's both scalable and integrated. And what we do is we have that core data service that then provides services to the kind of the middle layer of different kinds of data access patterns to that underlying data. So we expect more companies to move to this kind of model where the data management core is foundational, it's scalable, it's replicated, it's memory first, so you get all the performance and high availability benefits, but you also have multiple ways of accessing that data through different kinds of, whether it's querying, full text search, etc. And support for different kinds of deployment models as well, whether it's cloud or big data integrations, etc. So we have to have these multiple data access patterns, and we also have to have essential deployment capabilities on any kind of platform. So this could be, this just says Couchbase Data Platform. This is one example, but this is the kind of platforms that you need to be looking for going forward so that you know they will be able to grow and be tightly integrated to meet your performance demands in particular. So that's kind of the summary view of our system. This one here, actually, I don't expect you to read through it, but the goal here is just to overwhelm you with complexity. And really, we have a lot of different kinds of services in our platform. There's a lot of subcomponents in those services, but they're all abstracted away for the end user. And that's really got to be the goal, is to abstract them away from the end user so that they can use the pattern to access their data the way they want without having to really understand a lot of the underlying components. And I want to touch on one example for an integrated data platform kind of area that's growing, and that's really around analytics. So hybrid transactional analytical processing. We've got two different kinds of patterns that we see that different products manage, whether it's just a query service for OLTP or analytics service for OLAP. They're two different patterns, but really, you know, they're touching the same data at the end of the day, and we got to make sure these things are streamlined. Historically speaking, we've had this kind of model where it's moved data from one app to an analytic database, from your operational database to your analytic database, analyze it with a tool, maybe feed that back into some business knowledge. We can't really maintain that kind of model when we start talking about big data, large volumes, scalable transactions, etc. And so what we've taken the approach of integrating analytics directly into the database itself. So we have an operational database, operational NoSQL database with other integrated services, but analytics is another one. So we have in the core of the capability is a parallelized system. An MPP system allows you to do complex queries on large data sets without having to have an additional system or additional product in your portfolio to manage. So it's a checkbox feature. You turn it on and enable it on a node, and it's available in your NoSQL cluster. So you're doing ad hoc queries on JSON data, basically, in an analytics environment. That's really the kinds of approaches that we expect more and more people to adopt in the future, pulling in capabilities into the platform. You're already seeing it, not just with our product, obviously, but with others. Number two, kind of addressing the scalability challenge. We expect their unconstrained scalability is going to be a concept you hear of more and more of in the future. We all know that certain features certain products can only be scaled up and not be scaled out. You want to be able to scale out to having support for clusters that by adding more nodes, for example, to address certain specific workloads. I want to talk about a concept we call multidimensional scaling. Some databases do this approach where, yeah, you might have a cluster, but you're running all the same services on all the nodes in a cluster. Well, what happens when maybe you just need more indexing and querying capability because of the demand that you see from your end users? You need to be able to add nodes that specifically address that. And then also, likewise, on the right-hand side, what if you just need more RAM or more volume of data storage? We need to be able to add nodes incrementally that way. So that's our scale-out architecture that we provide, and you need to really be able to have that so that you can isolate workloads from one another. And similarly, what if you want to scale up some of these services, increase the capability on a node, or add another node? Like that flexibility is why we're calling it multi-dimensional scaling, because you can scale up, you can scale out, and workload isolation kind of comes for free within this kind of a system. We expect more demand for this kind of scalable architecture in the future. And to top it off, we also want to have geographic distributed replication across these kinds of clusters. So you're not only scaling out, but you're scaling across geography. And that if that isn't made easy to use, it will be demand for it to be easy to use in the future. We believe ours is very easy to use and is all through a web management UI. So I encourage you to try that out. So talking about geographic deployments, cloud deployments are going to continue to grow. But it's not just a single way of deploying in the cloud environments that's important. And we've talked a little bit about hybrid already, so I'm not going to go into it in any depth. But when considering cloud deployments here, it's always important to consider these three different models that I've chosen to talk about today. There's more. But private cloud it's huge. It's not going away. Enterprise users will want their stuff running on their systems that they maintain and manage. And then public cloud, everyone's familiar with that already. But you will see between those two, the commonality, especially is around, say, Kubernetes deployments and having support for containerized systems is really going to keep growing so that people can then move between these systems, or even between the third one there too, a managed service that somebody else runs and hosts for you. They're not going away, and each of these has their own management challenges, and that kind of leads to the next slide here, talking about the kinds of autonomous operation that you need for your databases, especially in the cloud. And I won't go into detail on every one of these items, don't worry. But we do need that automatic provisioning. We need things to scale up and scale down as needed. We need recovery so that when things do go bad, systems can take care of themselves, flag issues to administrators to deal with it accordingly. And then, of course, centralized management is the big one that I want to call out today. Expect to see that grow. We're going to have more tools, and you are seeing this around the Kubernetes infrastructures that are being developed today. And this is, again, just an overwhelming slide for you to look at. But if you think about, this is how Couchbase is developed on top of Kubernetes, and the autonomous operator, we call it. And it manages everything within the Kubernetes framework for a persistent NoSQL database. So you want to scale things up, scale things down, it can take care of it for you. So that's just an encouragement. If you haven't tried it or seen it in action, I encourage you to go check out one of our demo videos of seeing it scale up and down and fail over automatically, etc. It's pretty cool stuff. But there's going to be more and more demand for the management tools around cloud deployments, container deployments. So that's it for the 3 points here that I want to touch on today, addressing the integrated data platforms, unprecedented continued scalability, and then management layers on top of multiple multi-cloud deployments. All going to be important stuff for us going forward. So I'll take a breath now and turn it over to you. Thank you.
Thank you very much, Tyler. At this point in time, I'd like to introduce our final speaker today, Max Neunhöffer, Senior Developer and Architect at ArongoDB.
Thank you, Stephen, and welcome. My name is Max, and I'm indeed a developer and architect for ArongoDB. But since we are a small company, I do lots of stuff. So I do podcasts, as you can see. I give talks. I go to conferences, and I write blog posts. So that's life. And I also work with customers, and so I have a pretty good overview of what's going on. Right. I also want to tell you about my 3 highlights of trends in modern databases or data architecture. And I would like to start actually similar to what Tyler started with, with probably some other terms. I want to talk about multi-model databases. And this story essentially begins with the idea of polyglot persistence, which essentially is that if you have a complex system, you should, for each part of your system, really use the right data model to put your data into a data store which can work efficiently with it. So if you have key-value data, you probably want to use a key-value store. If you have graph data, well, you might want to use a graph database. So traditionally, the polyglot persistence has been described by saying you should do a microservice architecture and you should just deploy different data stores, each working with the right data model. Now, in a more modern world, I see a trend that this moves to a slightly different description, namely, you should use multi-model data stores which have the capability to work with multiple data models. That's not saying that you have to go back to some monolithic system which handles all your data models. No, that's not what I'm saying. I'm saying you can use fewer different technologies and still maybe deploy different instances, but your individual data stores have the capabilities to work with different data models. Now, obviously, you can just put together multiple data stores into one machine and then call it multi-model, but I want to particularly emphasize the trend towards native multi-model databases. These are data stores which are devised from the start as multi-model, and that means that they can offer a single database core and a single query language in which you can even mix the different data models in a single query. So let's look a bit at the market, what I mean with multiple data models. Even if you look at the traditional relational databases, then you can see that even traditional players like Oracle add support for JSON columns. So they somehow want to offer the document data model. So Postgres is doing the same. MySQL is doing the same. If you look at traditional document databases like MongoDB or like DataStax, Cassandra, what you see is that they add support for graphs. Yeah, so traditional single model data stores are moving towards offering more capabilities, more different data models. Neo4j, traditional graph database, is adding secondary indexes and document support. Redis, the key value store, is adding more and more data types, maybe even support for linked data and so on. And then, of course, you see the multi-model players like ArongoDB or MarkLogic or OrangeDB emerge, which are products which are essentially designed as multi-model data stores. And obviously, in the software as a service space, you see with DynamoDB or Cosmos DB also offerings which offer multiple data models. So that's actually already quite visible. And if you look at what we just saw about Couchbase, then we also see that there is different engines, indexing, and so on going on in the same data store. Let me quickly explain the particular multi-model approach ArongoDB follows. So ArongoDB is a document store with respect to JSON documents. It is a graph database, and it is a key value store. And we have carefully picked exactly these three data models and devised a common query language to unite them, because we can actually have a single core and just do all these data models and even mixtures of it. And I will say a tiny bit on the next slide why this actually works. The net result is that even though ArongoDB supports different data models, we can actually compete with respect to performance and versatility and so on with specialized products. So if you combine these three data models, there's no reason why it should be less efficient than a specialized document store. Likewise, there's no reason why it should be less efficient than a specialized graph database. So therefore, this kind of technology allows to come back to the idea of polyglot persistence, but you save a lot of complexity because you can use the single database technology to cover all parts which need these three data models or even mixtures. And let me reiterate, it doesn't say you should use a monolithic database in the middle of your project. No, you can have different deployments. You can have a smaller graph database in one corner of your project. You can have a large scalable key value store in the other. And yet you can have some place where you actually use all data models at the same time. So why does this work so well? So what we in ArongoDB actually do is that we store the graphs as documents. So we support the property graph model. That is, we have labels and key value pairs at each vertex and at each edge. Therefore, just to store things, it's a relatively nice choice to store vertices as JSON documents and to store edges as JSON documents. Now, that is your document store. What you now need to support graph queries in the query language is an edge index which gives you one operation extremely quickly. Namely, you need to be able to look up all the neighbors of a vertex as fast as possible. And that's what our edge index does. And therefore, if we now have a query language which can support all these three data models and which can implement graph algorithms, joins for documents, secondary index lookups, key value lookups, all in the same core, then you can do a native multi-model database. Right, so let me just quickly explain this slide. Here you see a kind of overview over the data store space, if you want. And to the right, you see increasing data complexity. That is, you have unstructured data and various forms of different documents. And in the up-down direction, you have relationship complexity. So particularly complex are graphs, which have a very, very highly interlinked structure, like social networks, for example. And so that is somehow where the different players fit. And with ArongoDB, since we support graphs and documents and joins and all sorts of things with these data models, we position ourselves approximately in this corner of this picture. Time is fleeting, so let me move on to the second trend I'm seeing. Distributed transaction, that is truly asset, fully guaranteed transactions in a distributed system, have traditionally been considered to be really hard to get right and to pull off at all, and are still considered to be hard. However, what I observe is that maybe 3-4 years ago, people would still say, that's basically impossible to do. And so therefore, customers even didn't ask for it. But if you look what the market does, and there are a few commercial players now actually doing distributed transactions. So traditionally, of course, Google Spanner as a closed system and only software as a service system uses atomic clocks and fancy technology to pull off distributed transactions and very difficult consensus protocols. FoundationDB, first as closed source and then bought by Apple and now open source again. Now CockroachDB trying to replicate what Spanner does without atomic clocks. That's a very interesting player. And FaunaDB, which uses the Kelvin approach. So there are players now which try to get into this space. And what we actually see is that there is now beginning demand for such asset systems which still scale. why is that so hard? The fundamental problem here is that you need to replicate, because otherwise you cannot be sure that if there's a failure, you still have your data. But the moment you replicate, you have to establish consensus across multiple machines. And that is a very difficult computer science problem. And in particular, with respect to, say, a large transaction whose action is distributed all across your cluster, to establish consensus as to whether that transaction has been committed or not, whether it is visible or not, that is really a hard problem. And obviously, this must not only work if things go well, but it also has to work when things go wrong. So you have to build fault tolerance into the system. And obviously, you cannot just take all your time. You need to use consensus protocols, and they tend to be slow. And so therefore, this unholy combination, distributed consensus and fault tolerance, and then making strong guarantees in a high-performance thing, that is really hard. And I cannot promise too much, but behind the scenes at ArongoDB, we are working hard to join the club of few players which actually offer distributed asset transactions. So stay tuned, there might be exciting news. Time is nearly up, so let me just essentially also reiterate something Tyler said. The third trend I observe is easy cloud orchestration. So obviously this is public cloud, but it's also private cloud, and the winning platform is Kubernetes. And so essentially we need a cluster operating system, and it seems that Kubernetes is the one which has made the race. So therefore, the fundamental statement here is, even if distributed applications are difficult and complicated and have a lot of moving parts, deploying such a distributed application, even with state, must be as easy as installing an app on your phone. That's the principle. And behind that is, of course, a lot of other ops problems like keeping something alive, automatic failover, rolling upgrades without service interruption, keeping track of volumes, and so on and so on. And this is what is the fundamental problem here. But it is also a trend that this is being solved with technology. And just to give you an example, this is a small YAML file with, 11 lines of code. And if I type a single command here to deploy this to my Kubernetes cluster, it takes a few minutes, and I have a complete distributed, scalable, fault-tolerant application with TLS certificates and alternate name and everything deployed in my cluster. So that is how things must be. And if I, for example, want to rolling upgrade, then all I have to do is edit this file, change the name of the Docker image, and the operator must do everything for me. And that is what we are working very hard at, to have this kind of fully automatic operator and support for easy ops, DevOps. And that is the third trend I want to mention. And this brings me to a close of my talk. Thank you very much. Here are a few links if you want to learn more about ArongoDB. And with this, I hand back to Stephen.
Thank you very much, Max. We're going to dive into questions from our viewers today. The first question is from Michael. Michael, if I'm trying to spot a trend in PMM, what dashboard would you suggest I look at to see critical data for my database server?
Good question. It would depend on the technology at play here. Like I mentioned, Percona specializes in the three most popular open source databases of MySQL, MongoDB, and PostgreSQL. Each of these database technologies have their own overview dashboards, and that would be probably the first place I'd start. It gives you a high-level understanding of the characteristics such as the uptime, number of connections, number of errors it's seen, and other important factors that you can use to evaluate the performance. So I'd start with the overview dashboards.
Understood. Okay, our next question is for Tyler. Tyler, everyone talks about technical performance when what they really want or need is to remove friction from business processes. for example, extract value faster. How are you seeing technology helping continue addressing this?
Yeah, we love our benchmarks, that's for sure, comparing technology against technology. But ultimately, I think most of that ties back to the idea of flattening the overall stack of technology that's required to deliver solutions. So if you think of business insight kind of being impeded by having to hand data between multiple processes, maybe the further apart those processes are, the higher the friction is. So that's really that's why I include the analytics example that I was showing of how we try to bring the services as close to the data as possible, and then just get out of the way between the user and the underlying data store. So there's obviously certain architectural kind of core principles you need so that you can do that and still have a scalable architecture. You don't want to just have a bolt-on capability that does one little feature but then doesn't scale, or that you can only read data from but can't write data to, etc. So I think we'll get away from maybe performance benchmarking for just reads and writes, and we'll start moving more towards how can we do more complex querying or integration with other tooling in a more efficient manner. And I think really that comes down to getting out of the way as fast as possible and keeping the integration layers really light in between things. I think that might answer the question.
No, thanks, Tyler. Max, our next question is for you. I've heard that one should not run stateful services in Kubernetes. Why should I run a database?
Yes, that's a good one. Common knowledge has it that Kubernetes is very nice for stateless services, and you should probably keep your stateful stuff like a database outside of it. However, if you look at recent years, and Kubernetes is moving at an incredibly pace, then they have added a lot of stuff. There's persistent volume claims, persistent volumes, and nowadays an operator for a data store can actually deploy persistent volumes. You can choose the persistent volume type. You have very, very close control where your data actually is. You have automatic redeployment, and in the presence of network shares as persistent volumes, you can even deploy a database component on a different node just with the same data. And so therefore, this common knowledge is changing. And if I now go out and give talks, say at a Kubernetes meetup, then half of the people say, you should stay away from stateful services Kubernetes. But the other half says, well, maybe this is a changing thing. And I really believe that in 2 years' time it has changed. And it will be relatively straightforward, and therefore people will do it to run stateful services in Kubernetes.
Understood. Thanks, Max. Back to you, Michael. If we need to spot trends in our metrics, can PMM help us identify database performance issues?
Absolutely. Like I had mentioned earlier, we have the overview dashboards that help you understand at a high level on a per server basis what's actually going on with your databases. But we also provide some significantly in-depth dashboards that let you examine things at the storage level of the operating system, such as the disk performance. We've got a great view of how the CPUs are working in concert together in a multi-core environment, which most deployments for databases are. And we also have a very niche product, which we call Query Analytics, which can help you spot the trends in terms of the queries that are new to your environment. We can help you quickly identify those. And those are commonly observed during code releases or any other modifications to the environment. And those let you view it at a historical level, how that query has been performing, maybe over the last 5 minutes, the last 5 days, or the last 5 weeks. So PMM is built from the ground up using open source tools to show you trends, both from a query level and also from an operating system and database service level metrics.
Understood. Thanks, Michael. Tyler, we're going to go back to you. Question is, hosting in the cloud has been made so easy for many applications. Why are we still talking about it today?
I'd say, yeah, really, it's like push button, turn on the cloud, right? I think Max covered off the persistence question really well there too, and a lot of people don't really get down to that level of managing their volumes and managing how their data is handled and persisted. And a lot of people just want to turn a service on and use it, but that might be easy early on in a development cycle, but as you move into a production environment and you move into the areas of wanting to have control over your data and move your service off the cloud or to another cloud or to a private cloud or to a developer machine, you need to have that kind of flexibility. So I think as we talk about making deployments more and more flexible, there's going to be more and more discussion about how to make them portable, and I obviously believe containerization is the way that's all going right now anyway. But if you think that cloud, if you've been focused on cloud but you haven't been introduced to containers, now's the time to do it for sure.
Gotcha. Thanks, Tyler. Max, our next question is for you. What is a typical use case for a native multi-model database?
Yeah, that is a good question, and it's hard to answer because there are so many different use cases. But let me give you my favorite one. My favorite one is a use case in aircraft fleet management. That is a case where somebody needed to store all the data about an aircraft fleet, in particular the fleet, and then of course all the aircraft, and then the parts of the aircraft up down to the least little screw. And it turned out in the end that the best approach was to use a graph data model, where you essentially have a tree of things, where on the top there's the fleet, and then you have a node for each aircraft, and then you have components of that, and so it goes down. And it turned out that to get all the queries needed in the system fast, you actually needed multi-model, because some of them are graph queries, which are only with a graph model fast, and others cannot use the graph structure at all, and so therefore you need secondary indexes across the graph. And what was very nice, that only a native multi-model database could essentially get all the necessary queries fast. But that sounds very special, but if you look around, there's actually a lot of use cases which can benefit greatly from having multiple data models at your convenience and integrated in the same query language.
Understood. Thank you very much, Max. Michael, we're going to head back to you. We have one viewer that says, cloud is fine if your apps are designed for the cloud. One also needs to understand the real costs of the cloud. Can you weigh in on key cost considerations when moving to the cloud?
Absolutely. It's a hot button issue, isn't it? What is very appealing about the cloud, as I'd mentioned, is how quickly you can get into it, how quickly you can scale. If you're not paying attention, you can get burned. You can get quite a surprise bill at the end of the month. And I'll articulate that the providers have made, I wouldn't say 110% effort to be as visible as possible on what those costs are. I think they've done their due diligence, but they haven't exactly said, here's how you can save money with us, because it's a little bit of a counterintuitive. So there's a whole host of other companies out there that are in a space to say, let's analyze your AWS bill and help you find some optimizations. The one that I stress and I find is really critical is that you look at those performance characteristics and recognize that on-premise can give you a very fixed cost. And if your workload you expect to be relatively static or some predictable growth pattern, maybe on-premise is a much better value proposition. But when you're in the cloud, it pays to continually be focusing on performance and ensuring that you're floating around, a 70, 80% utilization of these services. Further to that, there's other options that the providers offer by buying in advance, buying maybe a year's worth. If you're a large enough spender, you'll probably have an account manager. And in that sense, there are some incentives that they'll use to keep you on their platform. But if you've made a commitment, and you're very likely going to have to be making that commitment because moving between vendors is not free, and it does take effort that you'll have to sacrifice from some other area. So you will have to at some point commit to a cloud provider and say, all right, if I'm with you for a year or 2 years or 36 months, what kind of a number can we work with here to find a good, happy medium? And so I stress working with those cloud providers, but also holding them accountable by looking at the performance characteristics of your environment and also working with these other third-party, let me help you analyze your AWS bill kind of partners.
Understood. Thanks, Michael. Tyler, what is the largest Couchbase installation in terms of data volume?
Sorry, I think you're asked the wrong person. I don't know offhand what the largest instance is, so I probably shouldn't pull a number out of the air either at this point, unfortunately, Steve.
No problem, Tyler. Sorry about that. That's Tyler.
No problem.
Okay, moving on to Max. Max, how easy is it to migrate from Oracle to ArongoDB? What is the equivalent of PL SQL in Arango?
Yeah, that's a good question. So I've heard of cases where people simply take their tables, and for each table they take document collection in ArongoDB, just drop the data in, and the equivalent to the SQL language is our AQL language. It is different in syntax, but very similar in spirit, and it is relatively straightforward to rather mechanically transfer the queries. That works, and quite often that's actually giving you performance gain, and since we can do joins and stuff like this, that's actually very straightforward. However, I think if you do this easy route, then you are not getting the most out of the multi-model. Rather, you should probably make a little bit more homework and study your data model, because with a multi-model database, with the graph capabilities and the recursiveness of documents, quite often it is relatively easy to change your data model when you move and get a lot more performance and flexibility out of this step. And then it's unfortunately no longer an automatic process, but you have to work a bit. But the gains you can get are huge.
Understood. Thanks, Max. At this point in time, we have a few minutes left, so we're going to allow each speaker to provide final thoughts, key takeaways for our viewers today that are either just starting their journey to a modern data architecture or well on their way. So, Michael, why don't we start with you?
Thanks, Stephen. I'll just come back to that it's critical that you focus the cloud as part of your technology. It's probably an often repeated mantra, but there are some considerable benefits that make sense to both Percona customers and anybody out there who's operating a publicly accessible service or application. Also, I'll add that it's important to watch those costs, that they don't become surprises, instead that you can plan for them. And finally, focusing on database performance is probably the single most important thing you and your engineering teams can do. It'll bring you both additional revenue and also save you costs in the long run. If you're looking for any help around MySQL, MongoDB, or PostgreSQL, look to Percona. We'll help you both on a question and answer basis through a support contract. We'll help you with migrations through our consulting team and any other special projects you might have. And finally, we'll help you with our managed services offering if you're looking for someone to be your database, your virtual DBA. With that, back to you, Stephen. Thank you.
Thank you, Michael. And Tyler, your key takeaways and final thoughts.
Yeah, to add to those are all good ones. I'll go on about scalability, and I think oftentimes we do performance considerations, we do some benchmarking, and we see, we'll grow our cluster a couple times larger, 10 times larger, and see how things perform. But we don't often sit back and consider what the architectural requirements are to keep that scalability. And so talking about workload isolation, having scalable services that can scale out each on their own to meet specific demands of applications is really important. So please dig into any products you're working with to see how you can isolate workloads and also grow specific data access components according to your need. That'll help you manage your costs, and it will help you also understand the underlying principles that lead to a scalable architecture.
Understood. Thanks, Tyler. And Max, your final thoughts.
Yeah, very briefly. Look at data models. Get advice on them. There's a huge potential if you pick the right data model, and sometimes you need more than one data model. Keep an eye on distributed transaction. There's a lot happening there. And try things out. It has never been easier to deploy stuff to the cloud or to deploy to a Kubernetes cluster on bare metal. Try things out, give it a spin, and get advice about your data models. That's it.
Understood. Once again, I'd like to thank our speakers today, Michael Coburn, Product Manager, PMM at Percona, Tyler Mitchell, Senior Product Marketing Manager at Couchbase, and Max Neunhöffer, Senior Developer and Architect at ArongoDB. If you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived, and you'll receive an email tomorrow once the archive is posted. Plus, if you would like a PDF of this presentation, you can click on the resource icon at the bottom of your console. And just for participating in today's event, you could win this $100 American Express gift card. We're going to announce the winner on February 28th. Thank you, everyone, for joining us today, and we hope to see you again soon.